In today's class, we are going to learn a new technique called completing the square. Let's start by an example. Suppose I want to solve this quadratic equation x squared plus 8x plus 10 equals 0 using what we have learned in the last class by factorization. So then, x squared is obviously x times x. 10 can be 1 times 10 or 2 times 5. Well, you see that I have ignored the negative counterparts here because I want two numbers to add up to be a positive number here. Obviously, two negative numbers won't work, so I have ignored them. Alright, let's look at the first possibility here. 1 times 10. X times 10 plus x times 1 gives us 11x. And that is not what we want. We want 8x. Let's try a second possibility here. X times 5 plus x times 2 gives us 7x. And again, that is still not what we want. So obviously, this quadratic equation can't be solved by factorization because factorization only works over a set of integers. And this is why we need to learn a new technique called completing the square. Completing the square actually comes from something you have learned before called perfect square formula. Perfect square formula is basically this. A plus b, the whole thing squared, equals a squared plus 2ab plus b squared. Now we are going to change the letters so that they better fit our quadratic equation. So we're going to rewrite this as x plus a, the whole thing squared, equals x squared plus 2ax plus a squared. Okay, let's revisit that problem we couldn't solve before. X squared plus 8x plus 10 equals 0. Now, I'm going to put brackets around the first two terms here. They don't change the order of operation at all. What I'm doing is just emphasizing that we're going to look at these two terms specifically. Okay? All right, so I put brackets around them. Next, I'm going to rewrite this 8x as 2 times 4 times x. That's 8x. Okay, so this should look familiar to you. If you compare this with the perfect square formula here, x squared and x squared, 2 and the 2, x and x, which means our a is 4 here. So if I can add the a squared, that means 4 squared, which is 16, then I can have a perfect square here. So let's go ahead and do that. I'll add a 16 here. Hey, but I can't just randomly add a 16. That would change the equation. So what should I do? I should subtract 16 to nullify that effect. Okay, and then next, we are going to take this negative 16 outside of brackets. Okay, so I've done that. I've taken that outside of brackets. So you see here, that is our perfect square. We're going to rewrite this as x plus 4, the whole thing squared. N plus 10 minus 16 becomes minus 6 here. The rest is fairly easy. I will add 6 on both sides of the equation. And then I'll take square root on both sides of the equation. Notice that you must have this plus and the minus sign. Very important, okay? And again, I will subtract 4 on both sides of the equation. And these are my final solutions. I have two solutions. Negative 4 plus square root of 6 and negative 4 minus square root of 6. Okay? The next example we are going to look at is slightly trickier. It's when you get a quadratic equation and the coefficient of a is not 1 anymore. Alright, let's take a look. 2x squared minus 12x plus 7 equals 0. So here, our coefficient is no longer 1. It's actually 2 now. Alright, the first step I'm going to do is exactly the same. I'm going to put brackets around the first two terms, just to emphasize that we are specifically looking at them. Okay, so I'll do that. The next step, I want to make it look like my previous example. So what I need to do here is to take out that 2 outside of brackets. Okay, I'll go ahead and do that. I'll take 2 outside of brackets. So inside the brackets, now I now have x squared minus 6x. Next, I'm going to rewrite that thing again. And I'm going to rewrite it as 2 times 3 times x. And then this should look familiar to you. Okay, it's our perfect square formula. Alright, so notice that here we have minus instead of plus, but it's the same thing. It's the other perfect square formula. X minus a, the whole thing squared, equals x squared plus, minus 2ax plus a squared. Alright, so again, following the same logic, our a is now 3, which means I want to add 3 squared at the end of it. That's 9 to complete this square. Okay, so I'll go ahead and do that. And again, I can't just add 9 because it would change the equation. I would subtract 9 to nullify that effect, which means I haven't changed the equation at all. Okay? Now the next bit is the tricky part that students sometimes get it wrong. When you move that minus 9 outside of brackets, you need to make sure that you multiply it by that 2, okay, that coefficient outside of brackets. Okay, you can't just have minus 9 here. Okay, so minus 9 multiplied by 2, we have minus 18 here. Okay, so then the rest is exactly the same as the previous example. This one here is my perfect square. I'm going to rewrite it as x minus 3, the whole thing squared. And plus 7 minus 18 gives me minus 11 equals 0. I will add 11 on both sides of the equation. I will divide by 2 on both sides of the equation. Again, I will take the square root on both sides of the equation and make sure you have that plus and minus. Finally, I add 3 on both sides of the equation. And if you want, you can tidy up the solutions a bit by rationalizing the denominator if you want. Okay, so then we will have 2 solutions. Okay, so that is all for completing the square. I will assign you some exercise as homework here. Okay, so solve the following quadratic equations using what we have learned in this class, completing the square. And I will go over homework in our next video.